Hello and welcome to day 8 of Advent of Code 2023. So let's go and see the puzzle. As you can see, I have already solved it and I'm going to provide the solution in this video. So let's go here. There is a haunted wasteland. We have a map with some instructions that goes like this. We start at this node and then we look at the direction. Our direction is R. So we take the right one, which is this one. And from AAA we go to CCC. So we end up here. Then we take a look at this one and then the next direction, that is L. So from CCC we take the L, which leads to ZZZ. And here is ZZZ, which is the endpoint for us. So how many steps did it take? We go from here to here and from here to here. So 2 steps. Now it might get a little bit tricky. So for this one, for example, we get AAA, get the left, land on BBB. So 1 step, BBB, take the left again, land on AAA. 2 steps, AAA, take the right, land on BBB. 3 steps, BBB, L, AAA. 4 steps, A, L, BBB. 5 steps, and BBB, R. We land on ZZZ, which is the endpoint. It's step number 6, so it takes 6 steps. I think the instructions are pretty clear, so let's see the code. So here, first I would, as always, get the input, split it by new line, and get 3 different things: the nodes, the directions, and something in between. This is the thing that lies in between, so I don't need this. I will get the directions and the nodes or network. Then what I do is converting the nodes as from string to something like an object so that I can directly point to it. So using this and substring, I would get something like this, which in the end is something like this. So for example, if I have this as input, it will be, then of course I can take this as the starting point, and from this I can go to L and R. And then I would have an index for each direction, each of these, and then I have steps that will count the steps that I'm taking from going A to ZZZ. Then there will be a while, and while I didn't get to ZZZ, I will continue doing something. The first thing is that I would go to the next step in the direction. So starting from here, I would go to the end, and if I pass the end, then I would go to the L. So this piece of code does that. And then each time I would change the current to be the value that the current shows and the direction shows. So this is the part. Nodes.map of the current will take us to, for example, this one. And then directions, direction index. So for example, this one, if we are on R and we are at this will take us from PNM and R to BFT. And then we have moved 1 node ahead, so we add up to the steps and we go to the next direction, and we will continue until we go to Z. So yeah, so on part 2 it gets a little bit complicated. So let's go and see the puzzle. On part 2 we need to get all the points that start with A, so it's not a single node, it's an array of nodes. All the ones that end with A, which is this one and this one. And for each of them we take the step until all of them get to a point which end in Z. So for example, in the beginning we are at 11A and 22A, so we are here and here. We take the first step, direction is L, we end up at 11B and 22B. They are not Z, none of them is Z, so we need to continue. From 11B and 22B we get to 11Z and 22C. This one is Z, but this one is not Z, so we need to continue. Next time we get to 11B, and from 22C we get to 22Z. Now this time this is Z, but this is not Z, so again we need to continue. And we would do this until after 6 steps we get to a point when both of them are z. But that's not so trivial. The fact is that the number will get very, very big. So we need to come up with another idea, with a smart idea, such that we don't calculate all the possibilities. What do I mean? So for example, look at here. We go from 11a to 11b, and from 11b we go to 11z. So we already know that from a to z, 11a to 11z is 2 steps. But we need to repeat it 4 more times, because the other path has not reached to z. For this one, for 22a, we know that we go to 22b, and from 22b we go 22c, and from 22c we go 22z. So for this one it takes 3 steps, but we need to repeat it 2 times, which is the number of ways that we go from 11a to 11z. For one it takes 2, for the other one it takes 3, and we multiply it to get to 6, which seems to be 2 times 3, but actually it's the least common multiple of 2 and 3, which is the smallest multiple that those two numbers have in common. In a nutshell, LCM is the least common multiple of two values. So if we have, for example, 4 as one number and let's say 6 as another number, the multiples of 4 are 4, 8, 12, and so on. For 6 it's 6, 12, 18, and so on, and in this list 12 is the minimum number, or the least number, which is the multiple of both these values. So this is the number that we need to get. So to solve this, I would do the same thing. The mapping is just the same, but instead of having only one node, we have a number of nodes. All those that end with a is the current nodes that we have. Then for these current nodes, I would have a path length to see how long does it take for each node which ends with a to end up the node with a z. So I have this here to keep track of that value. Then I would have a loop for all of these, and I would get each of the nodes, calculate the steps as was here. So it's just the same as this while loop that we have here. And in the end, I would just push this number of steps into the path length. And here I would in the end get a path of, like, for example, 2, 4, 13, and so forth. And then I need to get the LCM of all of these, which is done here. I'm just getting the LCM of these two, which is 4, then 4 and 13, which is like 52, and then so forth and so on. And I would like that. So this is very important to remember. And LCM is just like this. It takes A and B and just multiply them together, divides by the GCD. If you need to know more about LCM and GCD, I will provide a link in the description to 2 articles that will describe these two in more details. So yeah, this is about it for this puzzle. I hope you have enjoyed the video and learned something, and see you in the next video.